Okay, so here I have an example question to show how you can solve problem related with subtopic 2.3. So we have a parallel plate capacitor which made up of two large parallel metal plates, each area of 200 cm squared and 5 mm apart. So the plates are charged to a potential difference of 20 volts. So yang kita nak cari adalah electric field intensity between the plates, the capacitance of the capacitor, the charge stored in the capacitor, and what happened when the separation is now changed. Okay, with the supply still connected. So keyword yang sangat penting lah. Okay, alright. So let's tackle the question one by one. So before that, just to keep on emphasizing that all of you, the value of the area, the distance, and everything else must be in SI unit. So bila nak convert, especially area, okay, cm squared, dia akan jadi darab 10 kuasa negatif 4 bukan negatif 2. So be alert kat sini because we have cm square. Okay, nak convert kepada meter square. So 10 kuasa negatif 2 kali 10 kuasa negatif 2. And then this 5 mm pula is referring to the value of D kecil. Okay, and convert to SI unit by multiplying with 10 to the power of negative 3. And then here is already the value of the potential difference. Ataupun simply dalam chapter ni kita guna simbol V sahaja. Okay, dah merujuk pada voltage. So yang first kita nak cari E. Yang kedua nak cari capacitance. Yang ketiga nak cari charge stored. Okay, so kita fokus soalan nombor 1, 2, 3 dululah. Okay, for question number 1, E. Okay, since this is two parallel plates, yang mana formula dia kita boleh apply equation nombor 9 daripada senarai. Okay, so E equals to V over D. So keep in mind, V kat sini adalah potential difference. Okay, bukan potential plate positif, bukan potential plate negatif. Okay, so do your substitution and simply tekan calculator. So very straightforward. Okay, ataupun nak guna Newton per Coulomb. Dua-dua unit boleh accept. Okay, janji tulis unit. Okay, number 2, the capacitance of the capacitor. Okay, so since diberi kat kita dalam sebutan area and the separation distance, so I'll be using equation number 18. Okay, alright. Kenapa saya guna 18 bukan 19? Sebab dalam soalan dia tak nyatakan apa-apa about dielectric. Okay, so sebab tu kat sini epsilon naught sahaja. Dalam arti kata lain, epsilon R dia adalah 1 lah. Okay, right? So do your substitution. So epsilon naught is the constant value. Okay. Substitute nilai dengan betul. Sebab tu conversion sangat penting. Okay, and then tekan calculator lah. So we have 3.54 times 10 to the power of negative 11. And the unit for capacitance is farad. Right, number 3, we have charge. So charge comes from equation number 10. Okay, the definition of capacitance, C equals to Q over V ataupun Q equals to CV lah. So C kat sini adalah jawapan yang previously. Okay, so if we did wrong there, so it will be affected for part 3. Okay, so be careful when it comes to calculation. Okay, so here is the answer. Right, 7.08 times 10 to the power of negative 10 Coulomb. So be careful with the unit. Unit for capacitance is farad, capital F. Whereas unit for charge Q is Coulomb, capital C. Senang nak terkeliru. Okay, so let's move on to question B. The plates are now separated to a distance 10 mm. With the supply still connected. Keyword yang sangat penting kat sini. Yang mana tadi kita dah tengok dalam previous video. Still connected means voltage adalah constant. So dalam arti kata lain, nilai 20 tu masih lagi sama. Okay, but sekarang distance yang berubah. Okay, so taking yang equation number 18. Okay, C equals to epsilon naught A over D. So, let's focus on C and D. Okay, yang mana C is inversely proportional to D. So, what we will have here, okay, the new capacitance yang akan wujud disebabkan oleh perubahan distance, okay, will be a ratio of this lah. Okay, since we have calculated the value of capacitance when initial D is being applied, and then we change the distance D. So, boleh terus guna kaedah ini. So, 5 mm bahagi 10 mm darab dengan capacitance asal dia tadi tu. Okay, so in other words, dia dah berkurang menjadi separuh. Okay, so here is the answer. Okay, alright. Ataupun sebenarnya kalau nak guna substitution yang normal kat sini pun boleh. Gantikan D yang baru 10 mm. You should be getting the same value 1.77 times 10 to the power negative 11 farad. Okay, and don't forget, next question, what is the charge stored on the capacitor? Kita nak cari dua benda. Okay, sebab tu kat sini, konsep sangat penting sebab to find the charge, we need to apply formula Q equals to CV. So, V kat sini, if you do not know remain constant, dia akan affect our answer lah. Okay, so here substitute the new capacitance. Okay, yang mana capacitance kita berkurang kalau tengok sebab apa? D bertambah. The relationship between C and D are inversely proportional. Sebab tu C berkurang. So, multiply with 20. So, we will get 3.54 times 10 to the power negative 10 coulomb. Okay, so here we have our final answer for the new charge. Okay, so kat sini soalan tak menunjukkan inserting a dielectric, but still soalan menunjukkan modification of the capacitor. Okay, by changing the parallel plates. Okay, the separation distance between the parallel plates. So it is still applicable under the same subtopic. Okay, selainnya boleh tengok soalan exercises from your buku tutorial and you can try to solve all the questions. Right, that's all.